Welcome to the Phenomenological Alliance channel. In this video, we will discuss the next question that phenomenology poses in the field of natural sciences, namely the problem of being focused on formulas.
Refraction is the bending of light as it passes from one medium into another. This causes objects submerged in water to appear shifted from their actual positions. Considering the question of why the refraction of light occurs, modern physics provides an interpretation that the refraction of light occurs because light changes speed during refraction in optically denser material. In a similar way, a metal ball changes speed and trajectory in a collision with water.
Light slows as it travels through a medium other than vacuum, such as air, glass, or water. The light has effectively been slowed. When light returns to a vacuum and there are no electrons nearby, this slowing effect ends and its speed returns to normal.
The speed of light corresponds to the wavelength of light, and it is also claimed that at the wavelength of light in some medium of a refractive index n is n times smaller than the same wavelength of light in a vacuum. The formula describes the relation of the index of refraction with the speed of light and the wavelengths of light that light has in a vacuum and a transparent material. For example, the refractive index of water is 1.33. According to the formula, it turns out that the speed of light in water is approximately 225,000 kilometers per second.
Let's examine whether the stated formula reflects the facts of real life. The wavelength of green laser light is 532 nanometers. The refractive index of water is 1.33. If the formula reflects physical reality, then the green laser light in water should become about 400 nanometers. 400 nanometers belongs to the region of the spectrum in the area of violet color. Through the experiment, it cannot be observed that the water illuminated by the green laser light becomes violet. The viability of the model is preserved by interpreting that the eye perceives the frequency of light, which remains constant across different media. However, this interpretation cannot explain what property of light changes when green laser light passing through red material becomes yellow. The only actual property that changes in such experiments is the color of the light. Elements of the mathematical model, like speed, wavelength, and frequency, draw from the mechanical analogy of a ball impacting a denser medium. They are modified as needed to preserve the model's internal coherence, neglecting the direct appearance of color.
Phenomenology delves into the question of the structure of experience. In simpler terms, it explores what we see and what is reality, namely what is that we should see. A significant part of modern scientific perspectives is grounded in the conviction that numbers are inherently truthful. For instance, through measurement, one can deduce that the average growth rate of a bamboo tree is 0.5 meter per year. Following these insights, we can formulate a mathematical equation of growth. Thus, we conclude that after 1 year, the bamboo will be about 0.5 meter high. After 2 years, it will be approximately 1 meter high, and after 200 years, it theoretically reaches a height of 100 meters. While this conclusion holds true from the standpoint of formal logic, it does not align with reality, because there is no bamboo plant known to reach a height of 100 meters. Phenomenology indicates that mathematical formulations must always be verified by real-world facts, and not considered as facts in and of themselves. In many areas of physics, The unwarranted belief that mathematical formulations inherently lead to truth has resulted in numerous illusory convictions. Mathematical formulas belong to the world of man's ideation world, and they do not necessarily describe reality. Through mathematical thinking, the subject of thinking can be completely separated from the object of thinking. In mathematics, a thinker can remain in the self-sufficient sphere of formal logic separated from reality.
Let's consider this problem from a different point of view, examining the question of whether white light contains all colors.